13, 14, and 15, we are solving a trigonometric equation modeling a real-world situation. And it says, suppose the height of the ground of a person sitting on a Ferris wheel is described by the following. H of t equals 18 minus 15.9 times the cosine of 2 pi over 5t. In this equation, h of t is the height above ground in meters, t is the time in minutes. The ride begins at t equals 0 minutes. So during the first 5 minutes of the ride, when will a person be 24 meters above the ground? So we're going to put 24 in here for h of t. Now we are going to use our calculator in order to evaluate these. Again, since this is in terms of pi, I know I'm in radian measure. So I need to make sure my calculator is also in radian measure. Somehow I got tilted a little crooked. Let me straighten that out. I wonder how long that's been like that. You guys will know. And so on my calculator, again, if you have the Casio, you're going to hit mode, and hit 2 so that you're in radians instead of degrees. Mode 2 puts you in radians. So my equation says 24 equals 18 minus 15.9 times the cosine of 2 pi over 5t. I'm going to rearrange this and solve this for the cosine. So I'm going to subtract my 18 first. So 24 minus 18 is going to give me 6. Then I'm going to divide by my negative 15.9. Now, what I'm going to do, first of all, is I'm going to figure out where my angle is. But I want my angle to be positive, and then I'm going to figure out what quadrants I'm in for cosine to be negative. So when I do this on my calculator, I'm going to do the cosine of 6 over 15.9. Notice I'm using the positive and not the negative. That's going to tell me my angle in quadrant 1. So I'm going to do, I better do inverse cosine. Inverse cosine. So shift cosine, inverse cosine, in parentheses, I'm going to do 6 fraction 15.9. I could use 6 divided by 15.9. And if I hit equal, it tells me that I am at 1.18. I'm rounding that off to the nearest hundredth, by the way. So it's really 1.183, but I rounded that off. Now this is in quadrant 1. I know that cosine is negative when the x value goes backwards, so I need to be in quadrant 2 or in quadrant 3. So I really need to take 3.14 minus 1.18 to be in quadrant 2, and 3.14 plus 1.18 to be in quadrant 3. So if I go ahead and do that, 3.14 minus 1.18 would give me 1.96, and 3.14 plus 1.18 gives me 4.32. Now, that is really equal to this. So 2 pi over 5t either equals 1.96 or 2 pi over 5t equals my 4.32. I have to solve each of those for t. So if I'm going to solve for t, I'm going to multiply by 5 over 2 pi. Same thing down here, 5 over 2 pi. Now, I just use the pi button on my calculator instead of putting in 3.14. If you do the 3.14, make sure you multiply by the 2 first before you try to do your dividing. That's why I use the 2 pi. So on my calculator, I'm going to put in 1.96 times 5 divided by 2 shift and the EXP key, which puts the 2 pi on my calculator. So 1.96 times 5 divided by 2 pi gives me 1.559, so 1.56 when I round that off to the nearest hundredth. Doing my other one, 4.32 times 5 divided by 2 shift EXP to put the pi on there. So 4.32 times 5 divided by 2 pi is 3.4, and I've got to round that off to 4 because there's a 7 behind my 3, 3.437, so 3.44. Those are going to be my two answers, either at 1.56 minutes or 3.44 minutes is when your person's going to be 24 meters above the ground. Key to this problem, whether this is positive or negative, we're going to put it in as a positive, find your answer in quadrant 1, and then change it to whatever quadrants you need to be in, whether it's 2 and 3 or 1 and 4 or whatever it might be, then do your conversion. Now on Alex, they're going to do it all at once. It's going to be a great big long problem. I found that it's probably simpler just to do it step by step by step, and hopefully you come up with your right numbers on your calculator. Again, make sure you're in radian mode on your calculator. So number 14, if we look at number 14, it says for a fixed location, the number of sunlight hours in a day fluctuates throughout the year. Suppose the number of daily sunlight hours in a particular location can be modeled by the following. L of t equals 12 plus 2.9 sine of 2 pi over 365t. In this equation, L of t is the number of sunlight hours in a day. T is the number of days after March 20th. So T0 means March 20th, T1 is March 21st, T2 is March 22nd, and so far. Suppose we start at T0, which is March 20th. During the first 365 days, when will there be 14 hours of sunlight? So again, we're just going to put the 14 in here. The 2 is already in there from their calculation. So do not round your answer to the nearest hundredth. And so in this case, 14 equals 12 plus 2.9 sine of 2 pi over 365t. I'm going to subtract my 12, which gives me 2, and then I have to divide by the 2.9. So this is positive, which is good. I'm going to use the sine, or inverse sine, of 2 over 2.9. That's going to give me my answer in quadrant 1. Sine is positive in quadrant 1 and in quadrant 2. So, first of all, figuring out our inverse sine. Again, we're in radian mode. Shift sine of parentheses 2 divided by 2.9, or 2 fraction 2.9, gives us, rounding off to the nearest hundredth, 0.76. That one's in quadrant 1. We don't have to do anything to move that one, but we also need to find quadrant 2. So if you think about quadrant 2, I'm going to subtract from 180. So I'm going to take 3.14 minus my 0.76. So 3.14 minus 0.76 gives me 2.38. Now I'm going to take each of those values, set it equal to my 2 pi over 365t. So 2 pi over 365t either equals 0.76 or 2 pi over 365t equals 2.38. If I'm going to solve that for t, I have to multiply by the reciprocal, so I'm going to multiply by 365 over 2 pi. Again, I'm going to use the pi button on my calculator just because it's a little more accurate. So I'm going to start off 0.76 times 365 divided by 2 shift pi. So the 2 pi is all together. Otherwise, you'd have to use parentheses around your 2 times 3.14. Pi button is much easier to do. My first answer 44 point, rounding to the nearest hundredth, 15, because I have 149. So I have to, oops. Oh, I'm rounding off not to the nearest hundredth. I'm not rounding where I'm supposed to. Round to the nearest day. That's why my answer doesn't look right. Rounding off to the nearest whole number then. Excuse me, my first answer then would be 44 days. My second one, I'm going to take 2.38 times 365 divided by shift, nope, not shift yet, divided by 2 shift EXP. So I have 2.38 times 365 divided by 2 pi. If I hit equals, I get 138.26, but rounding that off to the nearest day, 138 days then. So either at 44 days or 138 days is where I'm going to have 14 hours of sunlight. And one more of those, number 15. The population sizes of many animal species rise and fall over time. Suppose that the population size of a certain species can be modeled by the following. PFT equals 4,079 minus 1,207 times the cosine of 2 pi over 5t. In this equation, P of t represents the total population size. T is the time in years. Suppose we start at t equals 0 years. During the first 5 years, when will the population size be 4,800? So 4,800 equals 4,079 minus 1,207 cosine of 2 pi over 5t. So we would subtract our 4,079. 4,800 minus 4,079 is 721. Again, we end up dividing, so we're going to divide by the negative 1207 to equal our cosine of 2 pi over 5t. Again, when we do this, we want to figure out quadrant 1, so we're not going to use the negative. We're going to do the inverse cosine of the positive, 721 over 1,207, figure out what angle is in quadrant 1, then we'll change it to the quadrants that we need to use. So, in radian mode, shift cosine, parentheses, 721 divided by 1,207 gives me 0.93. That's in quadrant 1. We want our cosine to be negative, so our cosine is going to be negative in quadrant 2 or quadrant 3. So in quadrant 2, we are going to take pi minus our value. So 3.14 minus 0.93. In quadrant 3, we're going to take pi plus our angle. So 3.14 minus 0.93 gives me 2.21. 3.14 plus 0.93 gives me 4.07. So, we are going to say that 2 pi over 5t either equals 2.21 if we're in quadrant 2, or 2 pi over 5t equals 4.07 if we're in quadrant 3. Again, to solve that, we have to multiply by the reciprocal, so 5 over 2 pi. So, on my calculator, 2.21 times 5 divided by shift EXP, whoops, I forgot the 2, divided by 2 shift exp. So 2.21 times 5 divided by 2 pi gives me, what am I rounding to? Round your answer to the nearest hundredth. So I have 1.758. So I would have to round that off to 1.76. 1.758 rounds off to 1.76. Then I'm going to do 4.07 times 5 divided by 2 shift exp. So 4.07 times 5 divided by 2 pi gives me 3.238, so 3.24. So at 1.76 years or 3.24 years, the population is going to be 4,800.